Hello everybody, I will start my today's another live coding session. So in my today's video, I will solve this question, median of two sorted arrays. So in this question, I'm given two sorted arrays, nums1 and nums2, of size m and n respectively. And I will return the median of the two sorted arrays. The overall runtime complexity should be over log n plus n. So for example, if I'm given okay, so two arrays. The first one is 1, 3, and the second one is 2. Then in that case, the median of the kind of merged sorted list is 1, 2, 3. So the median should be 2. Yeah, so it should be returned. And for example, if nums1 is 1, 2, and then nums2 is 3, 4, note that each of them are sorted. Yeah. I will think of the kind of merged sorted list, which should be like 1, 2, 3, 4. So there are 4 elements. So for median, I will return the average of two center positioned numbers, in this case 2 and 3. So I will return 2.5. Okay, good. So I will think of some edge cases. But yeah, for me, what I will do is so clear. The input should be two arrays, nums1 and nums2, which are integer arrays, or maybe number arrays. And what we will return is the number, which is a median. Okay. The input should be the array 1 and array 2. And output should be num, which is median. Okay. So I will think of an example, but I've already done it. Just in case, for some edge cases. Yep. When each of array 1 and array 2 is empty array. In that case, we shall return. Oh, this cannot happen because n plus n is 1 or larger. So, yeah. But if there is only one element, or 1 or 2, or maybe some element in one array, but the other is an empty array, in that case, I just have to return the median of the, non-empty array. In this case, 1 or maybe 2. Okay, good. So I understood the question statement, and also I covered some edge cases. Probably there aren't any edge cases. Good. So example, I've already done it. But let's think of this case. Okay. So in this case, I think the brute force approach is I will create the concatenated list, which is 1, 5, 2, 3, and then sorted, it becomes 1, 2, 3, 5, and I will return the median, center element. So in this way, it will take log n time because n log n time because I have to sort the entire array. Oh, sorry, it should be n plus n times log n plus n. Yeah. So, but I think obviously I can speed up more. So I will use 2 pointers as the optimization. So let's say the index in the first array is I1, and the index in the second array begins from 2. Then I will always move the pointer, which is pointing to the smaller number. Yeah. So in this case, I move this one first. Then here, I will choose the smaller number 2. So this one is chosen as the next element in the merge to sorted list. And then I move the I2 pointer. So in that way, I can move the 2 pointers and I can scan element in a sorted way. I mean, what did I say? So I can scan element in either nums1 or nums2 in a sorted way. So in this way, I can find the center element. I just have to keep calculate the center index, and I try to find that number at that index. Yeah. So be more specific. If I have in total, there should be length nums1 plus length nums2 element. Yeah. This is the count of all the numbers. So the middle rank index is count divided by 2 or count divided by 2 plus 1. No. So I mean, if there are 4 elements, what I want is, I mean, the median should be the average of index 1 and 2. So I want 1 and 2 from here. I can calculate it in this way. Yep. So in this way, I can get index 1 and 2. And I will, return the average of center 1 number and center 2 number. Good. Okay. But if count is 3, what I'm interested in is only index 2. So in that case, it is possible that I think of this as another case by, doing the if statement for the odd or evenness of the count. But I think I can generalize this. If center 1, if count is 3, center 1 becomes now 1. And center 2 becomes 1, 2. So I can say the same thing. I can do the same thing as the case when count is even. In either way, if count is even or not, I can try to find the center 1 and center 2 index and return the average of them. I could generalize this operation. Yeah, so I will think of it this way. And that being said, my task is to find center 1 and center 2 elements in the sorted list. I can always find this, even if count is 1. This becomes 0 and 0. So I can find the center 1 and center 2 elements. Okay. That being said, the time complexity should be O of n plus m, which I just say n plus n. Yeah. Because I have to scan n plus n divided by 2. Sorry, center index is almost like n plus n divided by 2. And I have to scan until that index by moving the 2 pointers. So the time complexity should be O of n plus n. For space complexity, I don't need extra non-constant space because I'm just moving the 2 pointers. Yeah. Okay. So all the extra spaces are constant. So it should be the constant. Good. Okay, I will start the implementation. So I start from index 0 and 0. So okay, so I will tell what I'm doing here. So when I move the 2 pointers, I will keep moving the 2 pointers until either of them, sorry, both of them reaches the end of the list. Yep. So which means that if either of them is entering the range of the array, I have to keep going. So that's what I mean by line 50. Then in line 51, if I1 is already ended, I definitely have to choose I2. Yeah. And in line 54, if I2 is already ended, I have to move the I1. So that's what I mean by line 54 to 56. And in line 57, reaching here means that I1 and I2 are in the range of, each list. So in that case, I compare two numbers, and if I1 number is smaller or equal to I2 number, in that case, I have to choose I1. So I choose I1 and increment I1 index. And if, say, I2 is larger, in that case, I have to choose I1 and move I1 pointer. Yeah. Just in case, if nums I1 number and I2 numbers, these two numbers are equal, I can move either of them. But in this case, I move I1 pointer. Okay. That being said, my another task is to find center 1 index and center 2 index. So here, so let's call it center index 1 and center index 2. And also what I want is center nums. And I will return the average of center nums in the end. Good. Okay, so now we'll try to find center num 1 and center num 2 and push them into center nums array. Here, oh wait, I think I have to count how many numbers I've seen so far. Or maybe I can do, if I1 is index 1 and if I2 is index 2, then this number Okay, sorry. So I don't want to do that. I think it messes up. So let me call it merge index merge. So this signifies the index in sorted merged list. So every time I find a new number, I increment the index merged. So that being said, if I1 is equal to, so wait, I think this is so clear. I don't want to do that operation in each of the if statement. So let me do it in this way. I will update this flag. Yep. And here, before updating the index merged, oh, no, sorry. And also let me do this incrementation in each, like this. Okay. Now I can remove this. So if I choose I1 num, I increment I1. Otherwise, I increment I2. And in the end, I increment index merge. Yeah. So now what we'll do is, if choose I1 num, in this case, I will check if this I1 is equal to center index 1 or center index 2. In this case, I push this into the center nums. Okay. In the case of line 68, I do it in I2, like this. Okay. Oh no, an index merge. Okay, so now what I will do in the end is, actually this works, but also I can do if center nums has 2 elements, I can break because I don't have to traverse anymore. Okay, so that's it. Good. So let me quickly walk through my code with very simple example, like this. Yeah, by the way, I will check only this case, but probably I should check the case when some of these two, there are in total even number of elements. I should also test that. And also I think I should check if one array is very small and the another array has so many large numbers. In that case, I keep traversing this latter array in the end, in the iterations. I think I should also check this case. Anyway, I will try this. So Now total count is 2. So center index 1, this should be 2 minus 1, so 0. And center index 2, this should be 1. Sorry, total count is now 3. This should be this, and this should be 1. Yes, this is as expected because I have index 0, 1, 2. So I should return index 1 number. So in this case, I will return the average of numbers at index 1 at number at index 1. So eventually I will return number at index 1. So that's okay. So now center nums is an empty array. Good. I1 begins with 0 and I2 begins with 0. Yes. Okay, so in line 57, I1 0 is less than 2. Yes. I2 0 is less than 1. Yes. So I go to line 58. Choose I1 num begins with num, and in line 60 is not true, line 62 is not true, and line 64 is true. Yes. So ranks. No, this isn't correct. I should compare two numbers. So I will compare nums1 index 1, which is 1, and nums2 index 2, which is 2. And 1 is smaller than 2, so here in line 65, choose I1 num is updated with true. So I go to line 70, and now index merged begins with 0. So it's still 0. I mean, it's not included in the list 1 or 1. So I go to line 73 and I increment I1, which becomes now 1. Yeah. Okay, then I go to line 78 and ranks the center nums is still 1. So I don't break. And I update index merge plus equal 1. So this becomes 1, which suggests that the next number is index 1. Yes. Okay. Good. Oh, I found a mistake. If index merged is center index 1, yes, I should put it. But also if center index 2, I mean, in the case index merged is equal to center index 1 is equal to center index 2, I should put these two numbers. Yeah. So how can I make that change? I think what I can do here is I will have center numbers, center indexes as a set to remove the duplication. Then I will append this number if index merged. Sorry, I will append the current number if index merged is in center indexes. Yep. Then also here in line 80, instead of returning in this case, I would say if index merged is equal to max of center indexes. In that case, I will break because it has up to 2 elements. This takes only the constant time. And in also in line 85, I will return average of them. There should be 1 or 2 elements. and I return the average. Okay, I made some update, but basically what I want to say is now center index is the set of only index 1. So that being said, I will think of the second step. Index 1 is 1, index 2 is 0. In this case, just have a num begins with none, and because nums 2 is smaller than nums 1, it apply. I mean, we go to line 69 in this case. So this is false. So I go to line 76, and now index merge 1 is center index 1. Center indexes. Yes, 1 is in the set 1. So I go to line 77, and I append 2 to the center nums. Yep. Then I2 plus equal 1. So this reaches the end. Yep. And in line 80, index merged, which is 1, is equal to center index 1. Yeah. Sorry. So center index is max is 1, and index merge is now 1. So this is equal. So break. And I go to line 84, and now center nums has only one element. So the line 84 is met, and I go to line 85, and I return 2 divided by 1 is 2. Good. This is accepted as expected. So this is passed. Okay, I could spot on a mistake, which is good, and I'm pretty confident in my code, even though I couldn't cover some lines like this or this. Yeah, but I'm pretty sure as a whole, this code works. So I submit my code. Okay. Seems like there is a typo. This should be center nums. Good. Okay, accepted. So I can solve this question in O of n plus n time complexity with using the merge to sorted list alike approach. Good. So now I will talk about the second approach, log m or n time complexity approach. This is much harder. Yeah. And I think this is one of the most complicated question in LeetCode. So yeah, I will try it. Okay, so the second approach, this is much harder. So I will try this. Okay, so I actually already read the solution for this question. It was almost impossible for me to come up with this solution by myself. So I will try to explain what I learned from it. So let's say the list looks like this, and something like this. In this case, to find the median in the log time complexity, I will use the binary search. And especially I will use the binary search on the smaller array. Yeah. What I'm going to say is this. Yeah. So I will do the binary search on this array. Nums2. Oh, let me swap this just for the explanation. In reality, either can happen. But for this explanation, let me make the nums1 shorter. Okay, so I will do the binary search in this nums1 array. And yep, let's say I find some index I'm thinking of as the middle index. And I will think how many elements there are in the, before this middle index. So I can say there are 3 elements. And also I will think how many elements there are before the median or before the smaller center number. In this case, there are 7 elements. And here there are 7 elements. So the median should be, there are 14 elements. So it should be, median should be, wait, is this correct? No, let me make it one more element. Let me make it one more element added. Okay, so now nums1 has 7 elements, nums2 has 7 elements. So in the merge sorted list, what I'm interested in is index 6 and index 7 in merged list. Yeah. So that's what I'd like to know. For index 6, I can say there are 7 elements until this. So I'd like to know the position, which looks like this. Yeah. In this case, I'd like to know this number. Yeah. So in nums1, I've already find 3 elements. I don't know which one, but I find 3 elements. So remaining of 4 elements. So I should find 4 elements in nums2. So what I mean to say is, if this is index 6, I should find 4 elements in nums2. So I will try to find it. I will try to see. So 4 elements, I will see this. And what I find here is, what I can say is, end of the 3 element in nums1 is 4. And end of num2 element is, in nums2 is also 4. And I will ask if this one is really index 6. 4 in nums1. And I can say this is true because I can find 3 elements here and there are 4 elements here. And in total, there are 7 elements. And when I compare this and this, 4 is equal to 4, which is the end of nums2 of array. And this is smaller than 7. So fortunately, I can say this is exactly the index 6. Yeah. But I have to think some more cases, like say when numbers are very small here. No, I mean numbers are smaller here in nums2. In this case, this is still true, but let's think this way. In this case, this 4 is actually not index 6. Yeah, because I mean I can find it from looking at this element. This element 3 is smaller than 4, but the next element of 3, which is also 3, is smaller than 4. So this 4 is later than the index 6. So that's what I find here. Okay. Good. And yeah. So let me quickly write it down. So C index in this case 4, which is 7, no, 6 minus 3. So wait a minute. So this is index 2. So yeah, 6 minus 2 in nums2. And does it meet? So what I try to check is nums1 4 is between nums1, nums2, index 4, I mean, and nums2 index 4 plus 1. If this is met, I can say this 4 is at index 6, what I'm looking for. Good. Okay, but one thing I have to take care is it is possible that the index 6 is actually in nums2. In that case, how can I find it? So for example, yeah, like this case. In this case, if I choose this index 4, what happens is I will take a look at this, and this is actually larger. Sorry, I'm looking for index 6. Yeah. So this one, this 8 is larger than 4. This means that 4 is not index 6. And I have to find out that this 8 is now the index 6. So that being said, I will think of this and this number. Yeah. And I will check if 4 and 8 are middle two numbers. Yeah. So if these are middle number, what happens is it should be 4 and 8 from nums1. And also I will see 5 and 9 here. this should be, I mean, this should be in a sorted way. What I mean to say is 1, 3, and 4, 3 is okay. But 1, 4, 3, 5 is not okay. So what I mean to say is, I have to meet max of nums1 this. Yeah. Okay. So how can I find it out? So as I said, I1 and I2 are, I mean, for I1, I do the binary search. For I2, I recalculate it by 6 minus I1 in this case. Yeah. So if this is met, I can say these two numbers are kind of middle numbers. So, sorry, at least I can say, I don't know how numbers are here, but I can say these four numbers are sorted in this way. Sorry, the first half two numbers are, no. So, I mean, I don't know which of nums1, I1, nums2, I2 are larger, but at least I can say in this way. And I don't know which numbers there are, but they're actually larger or equal to these two numbers. So in that way, I can, because I chose nums1 and nums2, sorry, nums1 I1 and nums2 I2 are in the center position. So in this way, I can calculate the median. Yep. So okay, so let me start as the process. So the first thing I will do is do binary search on nums1, and for each middle one index, I would say I1 equal middle one index and I2 equal what is it? So 6, this is center min index minus I1, and check this is met. If yes, I can find the median. Yeah. If no, what I can say is, if, for example, this In this case, 4, 8, and 5, 9, what this suggests is this, I choose 4, and in that case, this is 8. So this is too large because it's larger than 5, which is the next element of nums1. So probably I have to choose middle later than the current one. Yep. And otherwise, in the case when, sorry, so nums1 is say 4, 5, and 8, 9. If it is like this, I will do row is middle plus 1. If it looks like this one is very large and this one is very small, in this case, I took middle is too much right because I choose too much bigger number than actual median. So I should reduce middle. Yep. No, high is middle minus 1. In this way, I do the binary search. Okay. That being said, as long as, the time complexity it takes is log of n1. N1 is the rank of, nums1 list. So if this is larger than nums2, I just have to swap nums1 and nums2 in the beginning. And in that way, nums1 is always smaller ranks, and it takes log of the smaller ranks. Yeah. Okay. Now time complexity should be O of mini m and n, and I will do the log. Yep. For space complexity, I actually don't use any extra non-constant base, so it should be O of 1 constant. Okay. So in find median sorted arrays method, I start this implementation. Okay, I've swapped. Now I will do the binary search. By the way, one thing I forgot to do is I have to find the index I'm interested in. So median index, it should be ranks nums1 plus ranks nums2 and divided by 2. Yep. Note that if total count is even, I have to think of, or I should say, I should return actually the average of nums. Yeah. And this. Yeah. So I will do this in the end. Okay, but anyway, I will try to find this median index first. And I will focus on this. So I do the binary search, as I said. And from here, this is the middle one. So actually, I can say this is I1. Yeah. So I2 should be this center main index -1, median index -1. So these are what I'm interested in. Oh, sorry. I will assume, I will check to partition until median, I1 and until I2. Yeah, this way. So I will check in line 36. Maybe I can rephrase this as, no, I think this is okay. In this case, I've found out. So, and if in this case, so how can I rephrase, say this? Yeah, so I can think of this to I1 and I1 plus 1 num and I2 and I2 plus 1 num as a kind of interval. So in this case, it's not as expected, but in this case, this is as expected. And in this case, it is expected. So I'm comparing the beginning of this and end of this, and also end of this and beginning of this. And this can be, maybe this can be so wrong. This is okay. So obviously I'm comparing these two numbers. Yeah. So let me update this line 62 into and also this one is not good. Yeah. So I have to meet and also I have to meet nums1 I1 plus 1 is larger than, yeah. No, wait a minute. I will check this is partitioned or not. Sorry, maybe this one is good. Is it understood? Is it understand? Oh, I will use this. And otherwise, it looks like something like this or something, yeah, like that. Oh, this is okay. This is okay case. But this is okay. But this one is not okay. Okay, so I can say, in this case, like nums1, I1 is larger than. And if they're equal, it's fine. In this case, um, I1 is too large. So I have to, yeah, do this. And otherwise, low is equal to middle plus 1. Okay. And in this case, okay, so I will go back to line 63. In this case, what I can do is, I mean, the larger one almost of nums1 I1 and nums2 I2 is the middle index number. And also, as I said, if the ranks is even, let me name it, is even in total. Sorry, is even total. Is total even count? In this case, I also have to think of the median too. So this is mini of nums 1 I1 plus 1 and nums 2 I2 plus 1. Yeah. So let me just rename this to odd count. So if this is odd count, I just have to return median. Otherwise, I return the average of median and median large. Okay. Good. And I shouldn't reach the end of the line. Okay, so this is basically what I can do. Good. But I think, oh, by the way, let me just rename this row 1 to just row and high to just high. Okay. And one thing I have to take care is I don't know, but is I1 plus 1 and I2 plus 1, is it always in the range or not? I think it's not the case because, for example, all the elements are quite large and all the elements are quite small. In this case, for example, the middle number is here. What I'm looking for is index 2. Wait a minute. Median index is 3. Is it really 3? 3 plus 3. No, it isn't. I have to do minus 1 before dividing by 2. In this way, the median index should be 2. So if middle is at 3, no, index 2, I should think of until index 0. No, probably, sorry, this should be I1 minus 1. Yeah. Because if this has sorry, no, I don't have to do this. Because middle is now, or I should say I1 is now 2. Median index minus I1 is 2 minus 2 is 0. But I don't include this. So sorry, I have to decrement it. So now I2 is negative 1. Yeah. So in that case, how can I compare this and this? I mean, 3 and something here, if there is, and 4 and something before. So definitely what I can do is I1 plus 1. I should put infinity here. And I should put minus infinity here. So in that way, I can generalize this case and I can use the formula I invented in line 70. Yeah. So let me work on it a little bit. I will call nums mini, or I should say nums first. Nums1 fast, nums2, nums1 mini, nums1 max. Yep. Yep, I record it in this way. Okay. So nums1 mini should be this. And nums2 mini should be nums2 I2. And for nums1 max should be basically nums I1 plus 1. But if I1 plus I1 is the end of the list, it should be infinity. Otherwise, it should be nums1 I1 plus 1. And in the same way, actually for nums2 mini, if I2 is equal to negative 1, it should be mass negative infinity. Otherwise, it should be nums2 I2. Yeah. And for nums2 max, I just have to do nums2 I2 plus 1 because I2 can be -1 or maybe 0. No, sorry. Even if I2 is -1, this becomes 0. And in the case when nums2 is empty, in that case, so what should I do? If it is empty, probably nums2 max, yeah, should be infinity. Okay, so let me include all of them in that way. I1, if I1 is smaller than 0, it should be mass dot minus infinity. And otherwise, this. Yeah, and if I1 is equal or larger than length times 1, it becomes like this. Yeah. And for I2, I do the same thing for like this. Okay. So that being said, I will update nums1 I1 with nums1 mini. And I will update nums2 I2 with nums2 max. For this one, this should be nums1 max, and for this one, nums2 max. Okay, and for nums1 I1, as I said, this should be nums1 mini. Okay. Let me double check line 70 to 73. No. Oh, no. This should be nums1 I1. Okay. Good. And for this looks good. For this looks good. Okay. So now let me execute my code. Oh. I just have to point this out. I never expected that I can pass this implementation in the first try. Num2. Okay, nums2 and nums1. Medium large is okay, so this should be nums2 max. Okay, so in this case, 1, 3, and 2, it failed. So let me check this median index first. So is total count, odd count true? Yes. Median count is 1. Yes. Looks good. And I1, I2 should be 0 and 0. Oh, no, this isn't correct. So I1 should begin with 0. It's okay. But I2, this should begin with 1. Hmm? Because I'm interested in the case when there are two elements. So actually, I want median index plus 1 element in total. And I've already found I1 plus 1 element in total. And I have to deduce 1 from here because I'm thinking of it in 0 index. So wait, so in this way, median index is 1. So 1 plus 1 minus now I1 is 0 minus 1. I should think of 2 elements and I've found 1 element. So remaining is 1 element. So minus 1. I do it and I get 0. Oh, this is correct. Sorry. I actually have to find I2 0. Yep. So now I1, I2 is 0, 0. Yes. And now it's 1 and 2. And let me print these numbers. Okay, so nums1 mini is 2. What? No. Nums1 mini is, this should be 1. Nums1 mini now I1 is 0. So nums1 I1. Ah, actually these are swapped already. So let me swap this so that I can check it easily. Okay. So now nums1 mini is 2. Yes. Nums1 max is infinity. And nums2 mini is 1. Nums2 max is 3. Yes. So what I will check is if this is met. Max of them, I mean, nums1 mini, oh, I think this is nums2 mini. Yep. So this is now true because max of these are 2 and mini of these are 3. So I'm pretty sure I've just come here. Okay, yes. And median is now, oh, so what this means is that I could find one median, which is a larger one of nums1 max. No, this should be nums2 mini. Yes, okay. Looks like it's accepted. I will submit my code. Okay, I think this is a kind of edge case, one of the edge case. I have to take care. So its total count is odd is true, yes. Median count should be 0, yes. I1 should be 0 and I2 should be -1. But the problem here is actually in line 76. What do you mean? So, let me swap these again. Okay, so nums1 mini, nums1 I1 should be 0. Least index out of range, nums1 I1. Why is it? Nums1 I1. I1 is where is it? I1, I2 is 0 and -1. And I1 is 0, so I will take a look at nums1 I1, which should be 0. I'm a bit confused. Seems like they're swapped. Sorry. I should check this one because nums1 should be shorter if I don't want to swap these for readability in this working through. Okay, so now I find the reason. So what should I do if nums1 mini is already -1? In that case, what suggests is that I start from here. Yes. So I can't find even one element here. One possible idea is I just treat this as the edge case. And so maybe in the beginning, if either is empty, I just have to return the median from the middle of one, non-empty array. Yeah. I think that works. Let's think if what happens if I put infinity here. In that case, yeah, I think it doesn't work. It makes it quite confusing. And I think it works when opposite. I know the opposite doesn't happen because there is at least one element in either of nums1 or nums2, and I swap them in line 62. So now nums1 has smaller number of elements. So this is edge case I have to handle here. Otherwise, nums1 have at least one element, so it works. So returns median, just like I did here. Okay, let me try it again. No, index out of range. No. When nums1 is length 0, I will return element in nums2. Okay, sorry. This one. Good. So I will try it again. Oh, no, I1 and I1 here. I've reached the end. Let me print them out. Okay, so in this case, nums1 is 1, 2, nums2 is minus negative 10, negative 9, negative 8. Let me swap them. Okay, so in this case, it begins with from this one. So I begin with 1, 0. Let me print them out in a separate lines. Nums1 is equal to nums1, nums2. Good, okay. So I try index 1 and 0, and it seems like I choose too big number. So now I should decrement I1. So I1 begins with 0, and I2 is now 1. So I have 3 numbers. Wait, why do I have 3 numbers now? Because what I try to get is index. It's okay. Yeah. Oh, it looks good. And I get 1 and negative 9. Sorry, what is the expected answer? So obviously the expected one is I think it's negative 8 is an accepted answer. Yep. So now I've got index 0 and 1. And if I have this one, this doesn't meet the expectation. But yeah, because in, where is it? In line 99 line 99 is now false. Yeah, nums1 mini is 1, nums2 mini is negative. Max should be 1. And nums1 max is 2, nums2 max is negative 8. So many of them should be negative 8. So it doesn't meet line 99. So I go to line 106 and nums2 max and nums1 mini, I compare them. Nums2 max is negative 8 and nums1 max is now 2. Why am sorry? Nums2 max and nums2 min. So in this case, I1 is now 0 and I2 is now 1. But this doesn't work. And I1 decrements nums1. I see. So what I found is that it is possible that I don't choose any number from nums1. That case is not covered. So I should start from -1. So again, I think I should cover this -1 case somehow, just like I fixed it as the edge case. So if this is -1, let me think what happens. If this is -1, I should say this is -infinity, and this should be 1. Oh, I think maybe this works. Okay, now it works. Good. Okay, in this case, this is one of the edge cases I had to cover. So if this is 0, count 1, should count 2. Yeah. Count 2 is length nums 2. Center index 1 is now 2 minus 1 divided by 2 is 0, and 2 divided by 2 is 1. So I return the average of them. Oh, this should be 2. Let me see what happens if I delete this now. It worked. Okay. Now this case passes. Because I start from -1. Yeah. And if I choose -1, I can immediately find the result because that number should be the median. Good. Okay, finally it's accepted. Let me clean up my code. Yep, I'm pretty proud of myself because this is definitely one of the hardest question in LeetCode. Yeah. Maybe not hard, but quite complicated to implement. Okay, anyway, I will quickly wrap up my coding session. So in this video, I solved the question median of 2 sorted arrays. So I was given 2 sorted arrays, nums1 and nums2, and I return the median of all the numbers in nums1 or nums2. Okay, and the first approach I used was to use the 2 pointers. I made use of the condition, that each of nums1 and nums2 is sorted. So, I could move the pointer I1 or I2 depending on the comparison of numbers at index 1 and index 2. Until I reach the median. So that's my first approach, which took all of n plus n time complexity. And for my second approach, I used the binary search. So I used the binary search basically in nums1. And for each element, I took a look at nums2 until some index. And that index is something which means that the nums1 in the first half and nums2 until that index And in total, there are exactly half of number of elements of the element in nums1 and nums. And I will check if it is really the kind of partition. So I will check I1 and nums1 and index I2 and nums2. These two numbers work as the partition in the merged, sorted array. And if it's true, which means that I found the median number, so I can return it. If not, I will move the I1 index in nums1 array to left or right according to the result. Yeah, so that's how it works. And this took log of mini mn time complexity. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.